Hey guys, Travis Gillespie here. In the last video, we used a straight line to help us prove how the interior angles of a triangle, they have a sum of 180 degrees. Cool. So let's move forward from here and talk about how we can actually classify different types of triangles based off of their angle measures or also based off their side lengths. So right now we're just classifying triangles, and there's two ways that we can classify triangles. So the first way we'll classify triangles, you would say it's looking at the interior angles, but I'm just going to write it if we're looking at the inside angles of a triangle. So the other way that we can classify a triangle, let's get our divider here, is if we're looking at the outside side length. So I'm just going to write outside lengths or outside side lengths of a triangle. Let's just finish this table off here. So sometimes you might have a triangle that has an angle measure of exactly 90 degrees. So putting 90 degrees here. So what this is telling us is that we have one angle that's exactly 90 degrees. I'm just going to write one angle, we'll use the angle symbol, is 90 degrees. Fix that angle symbol real quick. So what we would do is name this or classify it based off the information of its angle measure. Since it has one angle that's exactly 90 degrees, we would call this a right triangle. Let's move on and look at another type of triangle. So this time when I draw this triangle, I'm going to say that all of the angle measures are less than 90 degrees. So all angles, here's my angle symbol. I'm going to do apostrophe S because all of them are less than 90 degrees. So when you have angles that are less than 90 degrees, we call them acute angles. And since all of the angles inside of the triangle, they're less than 90 degrees, we'll call this an acute triangle. Let's move on to looking at one more. And I'm getting a feeling you'll be able to guess what the name of the next triangle is here. I'm going to go ahead and draw it up real quick. And we can see that one of the angles has a measure of, well, it's greater than 90 degrees. So let's go ahead and write that down. One angle is greater than 90 degrees. I'm going to fix that angle symbol real quick. Greater than 90 degrees. So when you have angles that are greater than 90 degrees, they're called obtuse angles. So this is called an obtuse triangle. Obtuse. O-B-T-U-S-E. Okay, so that's how we classify triangles based off of the interior measures or the inside angles of those triangles. Let's go ahead and look at how we can classify or name triangles based off their outside side lengths. Get our first triangle up on the screen, and I'm just going to make some numbers up. I'm just going to say, hey, you know what? This side length here has a measure of 3. This side length is 4, and this side length is 5. So I can see here that 3, 4, 5, none of these sides are the same value. So I'm going to write no sides. No sides are equal, or none of the sides are the same value. So we would call this a scaling triangle. And one trick you might be able to use to help you remember a scaling triangle is to think about fish, and fish have scales, and those scales are different sizes, so none of those are the same. So think of a scaling triangle as a triangle that none of the sides are the same value. Now, let's move on to looking at our second triangle. So in this next triangle, I'm just going to draw it up real quick, and I'll say, hey, this side has a length of 10, this side has a length of 10, and let's just put a 5 below. This side is 5. But I see that two of the sides are the same value, so two sides are equal. So when you have two sides that are equal, we call this an isosceles triangle. And one trick to help you try to remember isosceles triangles are to think about your face. You have eyes, and you have two eyes. You have two eyes that are on your face, so therefore isosceles triangle would be a triangle with two sides that are the same. And isosceles, I think I spelled that wrong. Let's go ahead and just do a quick erase here. I-O-S-O-S. C-E-L-E-S. So isosceles triangle, two sides are the same. Let's move on to our next one. We're running out of room, but I think I might be able to squeeze it in here. Before we start drawing it, let's think about this. We have one triangle where none of the sides are the same, another where two of the sides are the same. I'm getting a feeling you can guess what this next one will be. Well, we have three sides that are going to be the same value. So I could say, hey, this is a 5, and a 5. And we would say all sides are the same. Or all sides are equal. And this one's not, you don't really need a trick to remember it, because since all sides are equal or the same, it basically has the name already in it. We would call this an equilateral triangle. I-Q-U-I-L-A-T-E-R-A-L. And I'm going to slide the screen over in just a second. Triangle. So just let you see that one. Cool. So what we can see is that we can name or classify triangles based off of the outside side length of the triangle, or also the inside angle measures of triangles. And you're going to see in the future that you'll be able to take both the inside angle measures and the outside length of triangles and actually combine them. Cool stuff, guys. I'll see you in the next videos.